Imagine you're in an interview and the panel says, your model includes both square footage and number of rooms as predictors of house prices. The coefficients look unstable and even counterintuitive. What's going on? This is a classic sign of multicollinearity, when your predictor variables are highly correlated with each other. In simple terms, your model is getting confused because two or more variables are saying almost the same thing. Square footage and number of rooms overlap. They both represent house size. The model can't easily tell which one is really driving price changes. When this happens, coefficients start jumping around, and standard errors get inflated. Your model might still predict well, but the interpretation, the why behind the numbers, becomes unreliable. To detect multicollinearity, we use tools like VIF, variance inflation factor. A VIF above 5 or 10 is your red flag. You can also look at correlation matrices to spot variables that move almost in sync. Fixing it, you've got a few smart options. Remove redundant variables, combine correlated predictors into one feature, use regularization techniques like Ridge or Lasso, or collect more data to stabilize those relationships. The goal isn't to eliminate correlation entirely. It's to make your model both interpretable and stable. Let's bring this to life with a real business scenario. Suppose you're analyzing marketing spend. TV and radio campaigns often run together, meaning their budgets rise and fall at the same time. When both are used as predictors of sales, your regression model can't clearly tell which channel actually drives the revenue. That's multicollinearity in action, and it makes budget optimization nearly impossible. This is why addressing it is so important in real-world data science. You can use feature engineering to merge correlated variables into a single composite metric, or use regularization methods like ridge regression that penalize overly correlated predictors. These approaches keep your coefficients meaningful and your insights trustworthy. Here's how you might frame your answer in an interview. Multicollinearity means predictors are highly correlated, which inflates standard errors and destabilizes coefficients. I detect it using VIF scores. Values above 10 usually indicate concern. To fix it, I remove redundant predictors, combine correlated ones, or apply ridge regression to manage correlation through regularization. The key is balancing interpretability with predictive performance. That's the kind of answer that shows you're not just running models. You understand how to make them explainable and reliable.